So again,
Yep.
much of this is just a recasting of the things that we've said, although we will tease you and whet your appetite by showing you a little bit of data as well, and then speak clearly about what we're asking for and what we're sort of, how we hope to engage, what you'll get out of it, what we get out of it, etc. So you probably know this famous paper from 1982. This is the paper that is cited over and over again whenever we talk about the WHO 30x7 cluster survey. This, as of yesterday morning, this paper had been cited 852 times, and so you have perhaps seen it. And what I'm proposing that we do together as a group is basically to update the analysis that was in that paper. Because at that time, they had done about 60 30x7 coverage surveys using, and they were introducing this design and saying, we think it's flexible enough to cover most of the situations that people would need in the 1982 timeframe. But they pulled out design effects, what they pulled out were confidence interval widths and estimated coverage for 446 EPI coverage outcomes from 60 surveys at that time. And they show in a little table that's laid out almost in a graphical way that for the vast majority of those surveys, the confidence intervals are narrower than plus or minus 10%. And so then they suggest that this one size fits all design for that time period, you know, when you calculate a symmetrical confidence interval, that in most cases it will be no wider than plus or minus 10%. Even if coverage is at its worst value for calculating a proportion, of course, that's 50%, that gives you the widest confidence interval. In that situation, the design effect would be smaller than 2. And although they didn't talk specifically about design effects or intra-cluster correlation coefficients, it's implicit in their discussion that if you have a sample size of 7 in each cluster and your design effect is 2, and you're using equal weights, then the intra-cluster correlation coefficient has to be 1/6 or smaller. And so in the updated WHO manual, we say, hey, well, times have changed here. Coverage is sometimes near 100%, so, or near 0% in some sad situations. So we don't want to use a symmetric confidence interval anymore. We want to use a modern proportion confidence interval that has better behavior near 0 and 100%. We want to have flexibility to sometimes be asking for a more narrow confidence interval than plus or minus 10%. We need to have flexibility for different cluster sizes and for different stratum sizes. Maybe it's a district level survey where we expect higher ICCs, or a national survey where we expect lower ICCs. And then also we recommend now that the coverage surveys be weighted. When you add in survey weights that are not all equal, that inflates the design effect. And so that's a factor that they didn't have to deal with because they were doing self-weighted analyses. So in Annex B of our manual, we describe the design effect using this equation. It's got 2 terms. It's got a term that has to do with the clustering effect, where M is the average number of respondents per cluster, and ICC is the intra-cluster correlation coefficient. Sometimes in the literature, it's also called the rate of homogeneity, or rho. Sometimes it's symbolized using the Greek letter rho. And then this other term, which is not new to survey professionals, but is new to the vaccination coverage survey, though certainly the WHO one. This is the inflation for the fact that the survey weights vary. So CVW is the coefficient of variation on the survey weights, and the design effect gets inflated by this multiplicative factor. In the manual, we said if you're planning a post-campaign survey after a vaccination campaign and you don't have a value that you trust or want to use, probably it would be conservative to use in your sample size calculation to use an ICC of 1/6. And 1/6 is that implicit value from 1982, but we had seen many routine immunization surveys with ICCs higher than 1/6. So we moved the boundary for routine immunization surveys, and we said probably 1/3 would be conservative there. We shouldn't assume that 1/6 is conservative because it doesn't appear to be in every situation here. And then for that last term, we just did a little hand waving and said, well, if you don't know how your weights will vary, you should plan on it and inflate your sample size, maybe between 10% and 40%. You should make that factor, pick a value that's somewhere between 1.1 and 1.4 to inflate the design effect, which is the same as inflating the sample size. So what I'm proposing we do is pool the data sets that we all have and evaluate these recommendations, and maybe refine them either by changing them or making them more nuanced and saying, if coverage is high, here is a conservative value. If you think coverage is going to be a little lower, then you need to be even more conservative. So I want to evaluate and possibly update these recommendations for survey planners. And we know that these parameters can vary by these different features of the survey, features of the country context. So it would be great to be able to give some advice that's still quite broad and easy to understand, but that's either well validated or maybe a little more nuanced. So I know that we as a community, we can update this paper and make it for modern times, and that we can easily publish hundreds of parameter values from the many dozens of surveys that we have. And we can give some guidance to people like ourselves who plan vaccination coverage surveys. So we wrote these programs to pull ICCs and design effects and CVWs out of survey data sets. And then we've run them now on a couple of dozen data sets that we have here. These are surveys that we've assisted with in one way or another. We don't have permission to publish all of these yet, so we're working on that in the background, and we'll want everyone who works with us to get all the official blessing and permission that they need in order to publish them. But we're just presenting some numbers in aggregate here today. So we pulled ICCs for the things that I've listed in the documents, campaign dose, baby protected at birth from neonatal tetanus, and then for BCG, Penta 1, Penta 3, and measles, and for whether the child presented a card. So we have, of course, many other doses. We could have probably tripled this number of ICCs, but this is what we've pulled for now. And this is just a little teaser plot. So the x-axis is coverage. The y-axis is that intracluster correlation coefficient. And I put on some reference lines here. The first red line is at 1/6. So this was the value from 1982. And then the second line is at 1/3, which is the value we recommended in 2018. So we can see here that when coverage is high, 3/4 or more of the ICCs are below 1/6, and all except the outliers are under 1/3. When coverage is lower, then these box plots creep up, and now instead of using the older conservative value, we probably need to use the newer conservative value or go even more conservative. And these outliers are kind of interesting, although it's widely known and said that the ICC varies with coverage. And it is true that in the limit, if coverage is 0% or 100%, then the ICC has to be small and negative, but it can be very close to those limits, and it can still be very high here for reasons I'll show you in a minute. This is the same ICCs, just broken out by survey type. So on the left, we see the campaign outcomes from post-campaign surveys, SIA surveys. In the middle, from neonatal tetanus surveys, checking to see if the mom had enough tetanus vaccination so that her newborn was protected at birth. And on the right, we have the vast majority of the data, which are from our routine immunization surveys. So thinking about those outliers for a minute, I want to just pick one of those outliers and drill down and examine it a little more. In the 2018 manual, we recommend looking at each outcome using what we call an organ pipe plot, like this, where each column is a cluster. The shaded part of the column is the proportion of the respondents in that cluster who were vaccinated. And in this case, all 4 of these strata, there's one plot per stratum here, coverage is 50% in each stratum, but it's distributed in different ways across the cluster. In the upper left, 4 children out of every 8 in the survey were vaccinated in every cluster. So coverage is very homogeneous. It's homogeneously bad, but it's homogeneous. In the upper right, we have the complement to that. In half of the places they went, all of the kids were vaccinated. And in the other half of the clusters, 0 of the 8 that they vaccinated. This is hypothetical data for teaching purposes, but here it's a completely different situation. Coverage is still 50%, but the problems that the EPI program has to address and solve here are different than the ones in the first situation. And then the other two are a mix between those. And you can see the intra-cluster correlation coefficient for each of these situations. So just because coverage is 50%, that doesn't tell us the ICC. The ICC is describing how coverage is distributed across the clusters here. And when it's uniform, the ICC is slightly negative. It's -1 over M minus 1. And I just learned that last week. I always thought that when it was uniform, the ICC was 0, but I went back and got smarter, read some papers and got smarter last week. So that was a learning point for me. So if we look at one of those outliers from the plot with our data, it's a post-SIA plot from Ethiopia a few years back. Each column is a cluster. The red line shows us how many kids were in the sample in each cluster. So this is not a quota sample with equal number of respondents. This is equal number of households and interviewing all eligible respondents. So the number of respondents varies here from down around 8 up to around 24. And we see here that most clusters, all the kids were vaccinated, and then a few with medium, and then one that's quite low, and one cluster at the far right where none of the kids were vaccinated. This is a situation that leads to a very high ICC because coverage is highly correlated with space, with where the clusters are. So even though coverage was 86%, the ICC is big here. Remember, our conservative values are 1 over 6 or 1 over 3, and this is 2 to 3 times that, or 2 to 4 times that. So the design effect is very big here. So I think it's worth our talking about in the papers where we write about this, and just mentioning that when people, if you didn't even look at the organ pipe plot, if you show me a stratum with a high coverage and a high ICC, then I know that the organ pipe plot is going to look like this. And for a campaign, that means some areas were probably missed. So there is some signal there, even in those outliers. So I think there's something, we have a few things to talk about there as well. I don't know if you want to plan for the outliers. You probably don't want to use a conservative value of 0.6 in your planning because that would lead to a sample size that was very big. So you want to cover most of the strata with your sample size, but then in the analysis at the end, there can be some signal in calculating what was the design effect, and there can be some signal in looking at these organ pipe plots. This is the last data slide I'll show you, and then we'll just talk about what we plan to do. Here I've taken the RI ICCs and I've just broken them up by outcome. So BCG, did the kid show a card, measles, and the pentadoses. And we're painting with broad strokes here. This is still aggregating over different sizes of strata, and it's aggregating over a number of subgroups. But if I were painting with a broad brush here, I would say it looks like card availability is more homogeneous, even at different coverage levels, more homogeneous than, say, the distribution of the Penta vaccine, because the ICCs for cards are lower than the ICCs for Penta, except when coverage is really high. So it's interesting that the kids all have cards, but they don't. It's not that they all have cards, but half of them have cards. But the distribution of the cards is more homogeneous than the distribution of the vaccines. Is one thing that's being said there. And we can talk as a group of co-authors as we gather our data set about, well, how many outcomes do we want to show? And probably we want to focus in the main text of the paper on the outcomes that are used to plan the surveys, because that's the premise of the paper, that we're updating, we're providing some parameters for people who plan these surveys. So probably for a routine immunization survey, we're going to focus more on Penta 3. But I think it's interesting to show, possibly a little bit in the body of the paper, and certainly in a supplement, to show how the ICCs in the same population, how they vary across outcomes, and how there's some signal in that as well. So that was just to whet your appetite and get the juices flowing. We want to extract the parameters I've been talking about for the kinds of surveys I've been talking about, and then we'll stratify them and show that they vary by these different factors. They vary by outcome and by coverage, by size of the stratum. It also makes a difference how the survey selected the household within the cluster, and it makes a difference as to whether the survey protocol was to use only one respondent per household or to use all of the eligible respondents in a household. Because of course, the respondents in a household are very highly correlated with each other. And we'll comment on updating basically the guidance in the 2018 manual. So what the way we'd like to engage with you, it depends on what your role is for the different, in this community or this world. If you were the PI on a survey, then we'd love to have you facilitate, if you want to engage and contribute your data from your survey and participate in this exercise and be a co-author with us and help shape the advice so it's truly useful, then your job probably would be to facilitate communication with your data manager and have them either follow our guidance to extract the parameters and send the output to us, or to coordinate sharing the data with us and we can extract it with them or for them. If you were the consultant, then again, it's facilitating communication, letting the PI of those surveys know about this, helping get their permission to share these results, and then communicating with the data manager to do the work or to share the data. And if you were the analyst and you have the data, then we'll work with you to extract those parameters, and then we'll need you again to facilitate that relationship with the PI. And in some cases, there are people in this community who are not closely affiliated with a particular data set or survey, but they do help plan surveys. And so we'd love to have some people help inform, what we emphasize in the paper, what we show and how we show it, so that the end product will be useful to people in this community. So we're casting a wide net, inviting people to participate, and then in order to shake loose those permissions to use the data, we're offering co-authorship to the PIs or whoever is the government gatekeeper for permission. And then people honestly can be as deeply involved or little involved in writing the first draft or reviewing the drafts. We'd like to have everybody sort of review and approve, of course, of what we say and think about how we make the data available. There will be too many data points. If you look at some of the ICC papers I put in the Dropbox, sometimes people publish tables of ICCs. This was the outcome. This was the ICC from this study. I think we're going to have too many to publish tables of individual values. I think we'll publish things like box plots in a stratified analysis, but then probably in a supplemental resource, we will publish, share the data set that has all the ICCs and those things. I've mentioned several times that we can help do the work or spin you up on using our programs to do the work or with you or your staff. I had this idea to write this paper in 2013. This was even before, just as we were starting to pull together the WHO guidelines. When I drew the straw of writing the sample size portion of the new WHO manual, I said, well, I want our advice to be, data driven. And it didn't happen for several reasons. I thought we would use DHS and mix surveys to just grab a whole big pool of these values and publish them. But when I contacted the folks at DHS, they said, oh, Dale, we have so few respondents who are aged 12 to 23 months. Many clusters yield 0 respondents in that cohort. Many of them yield only 1 or 2. And so a correlation estimation for that narrow age cohort from our data set, the ICCs, they will be very numerically unstable. They will probably not be appropriate for planning a WHO EPI survey that's focused primarily on vaccination coverage. So I appreciated that feedback from them, and then this has been on the back burner since that time. So I think we should write a paper about updating the 2018 guidelines, but then I think we should also do a second or third, a later paper, where we evaluate that, where we look at ICCs from DHS and mix, and then from the EPI surveys we have from the same country in the neighboring year, and see how far badly wrong do you go if you use data from the DHS or mix that has those undesirable sample properties. So that's what I'm listing at the bottom of this slide. First, I think we focus on paper or papers, we'll see how much we have to say. I don't know if it's one paper or if we split out routine and neonatal tetanus and then split out advice for surveys for vaccination campaigns. We'll just have to see how much we have to say and where we're planning to publish it. I'd kind of like to publish it in the bulletin of the WHO. That's where that 82 paper was. I think it would be a nice complement or update to go there. But depending on our length and things like that, we'll have to discuss that as a community of co-authors. There are pros and cons to targeting that particular outlet.